aluminum curtain walls have the limitations for its structurally sound, both for the dead load and the wind load deflection. So generally, when you have a curtain wall project, you will see the specs by the architects that specified the type based on the average conditions. But when you actually implement, you need to know or consider the structural condition. Sometimes you need to change, but the changes need to be approved by architects before you doing that. What determines the material's structure? One is from the type, for example, aluminum or metal or steel or something else, or wood. Second, the shape of the materials you use. The shape, there are some properties determined, like moment of initial of an area. So you can find out basic concept of the moment of initial from the website. Here I have a link, like they introduce what is the moment of initial, so how it works, how to calculate for each shape.
And if the y-axis is our reference
So
axis, we can calculate I.
here is example of what I used for my project. The specs says we use Corning 1600 System 2 SSG system with vertical, and the back section is 5 1/4. This all most of typical back section is the same. But we found out they have problems for these big curtain walls, since the center distance between the verticals is so wide and the glass is so big. So, and then we check the book from Corning that the allowable the height of the molding you can use. So that's access to this one, because this one you need about 20 feet. What are we gonna do? So we have to insert steel or choose big back sections. For example, this insert steel moldings, the back section is the same, but we insert steel to make this stronger, to can build the frames as tall as about 20 feet high and hold the glass. Or you choose big back sections. This one is the same back section. But this one is big. This just same as rest of them. Which one you're going to use is up to the approval of architects, or which one you prefer to, because insert steel they can need more labor for fabrication, because you have insert steel, you have to screw together. You also need more installation hour, since this insert steel verticals is more heavier than the typical. So based on the moment of the initial of material shape, each material you have their own moment of initial based on the shape. Doesn't matter your steel or your aluminum. So you can get moment of inertia to the X or to the Y from the material provider. For example, this one, you can see they already put moment of inertia to X and section moment of inertia S. You also can get that properties from AutoCAD if you have the drawings of the extrusion or curtain wall. For this one, for example, as long as you region the profile and then you use command, you can get property of this extrusion. So you can find out what is the moment of inertia. So you find out moment of inertia X 12.73527 whatever. So it's the same as showing in their book. So to better understand how the insert steel to improve the structure, so we change the extrusion, since the extrusion is too complicated, to the equivalent rectangular shape of the material based on the moment of inertia equations for rectangular shape. So you have two equations, so you can get it width and height, deep. So based on this situation, you get width is 1.72 and the deep is 4.46. In the same way, we can get the moment of inertia for structural steel and get equivalent of how wide, how deep. So the important is how to combine these two materials, because one is aluminum, another is a steel. So we have to find out the ratio of Young's modulus, because Young's modulus is basic property of the material. Each material you have Young's modulus. You can get it from the engineer book. So the ratio is aluminum to steel Young's modulus. Aluminum is 68.98, steel is 205. So you get a ratio here. Based on this ratio, you can convert steel to the aluminum or aluminum to the steel. So here, because we are aluminum curtain walls, we want combined is aluminum. So use the engineer book, you can get combined or combined equivalent moment of inertia. So you get combined to the aluminum moment of inertia to the X and to the Y axis. So you can get equivalent of combined width and deep. So here it is how they change combinations of structure. The blue one is original curtain wall equivalent shape, and this red one is combined after aluminum and insert steel. So that means you do change the bigger of the rectangular shape if you consider as aluminum. You can do it the same way if you consider steel, but you have to change the ratios reverse. Then, based on your rectangular shape, a moment of inertia changed. So they're going to improve bending moment based on the standard simplified. I just show you example. This is simplified unilateral wind load, and we just flip over. Then we can simplify the moldings consider the wind load, and you get maximum deflection, you get maximum moment of inertia in the middle. Since maximum deflection, you can find out the formula from the engineer book, okay, because they have revert rate to the moment of inertia. You also get maximum bending stress is also revert rate to the moment of inertia. So it means moment of inertia getting bigger, your maximum deflection is getting smaller, and also your maximum bending stress is getting smaller. It means your current walls get more stronger. So you also increased the vertical load based on Euler equation. Since the load is ratio to the moment of inertia and the Young's modular. E is Young's modular and I is moment of inertia. So moment of inertia getting bigger, so your vertical current was getting more stronger to hold the dead load. Here is the data from Carnier website that is materials basic properties to resist wind load. So this is what we use materials typically is 16204. If I say the 5 feet away of vertical molding between of the curtain walls, so then your curtain wall can up to 15.5 feet height. That is not satisfied for this kind of situation because this one is 20 feet. Then if we put insert steel, same width 5 feet away, then you can up to almost 19 feet. So this is close to, but still a little short. If you choose different, the bigger section, which is instead of 5 1/4, we use 8 1/4 back section, big curtain walls. 5 feet will be up to 22.5. So then this is good enough for these applications. This is why we choose the curtain wall vertical moldings to the big back section. I hope this video better understand to how the insert steel improves the curtain wall structure. Thank you for your watching.